Hello viewers, my name's Alan and welcome back to my home workshop. So in this video I want to continue my quest for a good way to sharpen drills. So I've already done one video which explains the basics of drill points and the things that are important to that, and we had a look at using one of these jigs for better or for worse, and found that it can actually do a pretty reasonable job for small drills, or drills probably in the range 5mm to 12mm. Beyond that they don't fit and the clearance angle gets out of whack. So today I want to look at four-facet grinding. So when you and it's really quite a different approach. So when you sharpen a drill using the conical point method, you typically have to hold it in a jig or by hand and rotate it as you go like that. It's a sort of a round, and it's a three-dimensional or a compound action. So the drill presentation to the grinding wheel isn't constant, it's a dynamic thing, and you get the cutting and the clearance angles generated in the one process. But for facet sharpening, and I should preface any further comment I make by saying this is all academic theory for me. I have yet to do a four-facet sharpening. I haven't even got a drill in the shop, I don't think, that's been done that way properly. I've got some that are a bit like it. So this is theoretical for me, but hopefully by the end of this it'll be some practical experience as well. But anyway, with the four-facet process, as the name suggests, the drill points formed by grinding flat faces or the facets. So I think this concept's easier to grasp and visualise than conical point. Basically you achieve the grinding by holding the drill still, as in its angle doesn't change while you're grinding, and you move it in a straight line backwards and forwards. And as a result, the four-facet process creates the cutting and the clearance angles in separate steps. So there's basically 4 steps to it. You do the primary angle on one flute, flip the drill over, primary angle on the other one, then you do the secondary angle and then flip the drill back again. So it's 4 distinct steps. So the requirements for the design of the jig are actually very different, and we'll start to have a look at that. But what I want to do in this video is put together a prototype or a mock-up of a jig which I hope will work, but which is designed just really to showcase the issues that I've got to consider, and so I can have a proper look at what one of these drills looks like. So there are big implications for the design of the grinding jig, and it's important to understand the accuracy versus repeatability requirement for each aspect, because in some situations you must have a fairly precise measure, but in others the actual metric, if you like, the actual number of a degree or whatever, isn't particularly important, but what is important is its repeatability. So anyway, I've looked at lots of commercial, through the power of the internet, lots of commercial and shop-made jigs, and distilled out of that what seemed to be the key points to me. So I've got a picture here which I want to talk to. So as you can see, with a four-facet grind, the point has got primary and secondary facets. The primary facet's got an edge or a lip that does the cutting, and this is a relief angle that enables the cutting action. And the secondary facet is there to provide the clearance angle. But it's really that primary facet that does all the work, and that's where the critical angle is. So I've got a bit of a chart here which I'll talk to, and it's distilled from some information published by one of the jig vendors. So looking at the chart, you can see that there's a median relief angle of about 10 degrees. But for optimum results, it gets smaller or gets reduced for larger drills and harder materials. But the secondary relief angle is not critical at all, I gather, and 25 degrees seems to be suitable for every application, so that's a bit of a constant. So with all that understood, or accepted for the moment for me, I want to have a look at putting a jig together, and my first shot's going to be using various scraps and bits and pieces. So I'm going to base this design for this prototype, proof of concept type thing, on a design which was passed on to me by one of the viewers. It's very simple and basic, and it's perhaps not the easiest of things to use, in that it doesn't have properly integrated adjustments for all things that you would consider, but it's a good starting point. So for the jig that I'm going to make, I've found a piece of angle iron. I think it's 25mm angle iron. Size isn't very important, and I've got a volunteer drill here waiting to be sharpened. So what I'm going to do, rather than weld things up, is just work with bits and pieces that I've got. So I'm going to use as I'm going to put this on my AR5 tool and cutter grinder, so I don't need to worry about supplying a grinding wheel. That's already sorted. I'm going to use this base plate that I used for that for this, and it's just a lump of steel that was lying around. You can see it's got various holes from previous lives, and I've just, where these holes are massively oversized, just found some bushes to put into them, just to reduce them to a relevant size for the current job. So we'll lose that, and I'll be putting that bush in there, and that's going to give me the, and a T-bolt, that's going to give me the way to bolt it to my table. So that's that bit taken care of. Now I need a way of holding the thing up at some sort of an angle, of course. So we're assuming now that it's going to be on the table like that, with this mounted something like that. So I need a way of holding it off. So I've found this old exhaust pipe bracket. So that's also kindly volunteered. So we'll reuse the bolt from the mounting the other jig. Put that on there. Don't know whether this is going to work. We're doing this sort of real time. We'll see. But one of the reasons for doing this is I don't know what size to make the various bits for this jig yet. So this prototyping exercise is to find that out. So now I've got to hold that at this sort of an angle here. So I've got hold of a piece of 40mm wide, 3mm thick plate, bent it at 45 degrees. And I'm just going to clamp that on there. Oh, and I've drilled a hole in it. Drilled a hole in it so I can mount it on there, and I've got the bolt here with a square head, which will engage in the slot in this exhaust pipe bracket. It's very low tech, this, but for prototyping and proof of concept you don't want anything else. It's got to be quick and easy to change, no commitment to it in case you got it wrong. So that'll go on there, something like that, and we'll have this on there. I wanted to get a bit of additional support behind it, so I had this big I wanted to get a bit of extra support behind it, so I had this big washer in mind for that. Alright. Just snug that up a little bit. So now I want to get that, hold that on there. The old tool maker's clamps will do that job quite nicely. So now we've got the basics. We've got we can set the angle, which will be the drill point angle, by rotating this on its mounting. We can get the clearance angles by moving this to an angle. So we obviously then need to be able to set those angles. Well, I think what I'll do for that is use a digital angle setter. There's another suggestion from the guy who mentioned this design to me. So that's a pretty simple way of getting the angles set. So that's that. And we need a way of securing the drill, and that has to be done so when you take it out to turn it over, it goes back to the same place. So we'll put a dowel pin, because it's convenient, in the bottom of the channel, clamp it in place with another toolmaker's clamp, and now we've got some repeatability there. So that's given us most of what we need very quickly, but one thing it hasn't done, which I understand is very important for this 4-facet grinding, is a way to set the lips. In this jig, the lips have to be horizontal. It's very important that they are exactly horizontal, because if they're not, when you grind across them, you finish up with different length lips, and then it won't drill the correct size hole. So we need a way of setting that angle, and for this exercise, and it really should be quite simple to use as well, but for this quick and dirty, I'm not worried about ease of use so much. Not worried about ease of use so much as just getting something out there. So what I thought I'd do, this is just a dial gauge holding base, whatever. So that's going to allow me to stand the digital gauge there, and I'll be able to sight the drill lip to get it right. Now unfortunately I'm going to have to reset it each time I move the drill, so that's going to be a bit of a fag. And in the a better implementation of this design, there's an adjustable stop. There will be an adjustable stop put here, so that you can set the drill angle, set the drill rotation to get the lip horizontal, and then it's an easy repeat. But that's a refinement which we'll come to. So let's go and put this on the machine and have a better look at how it's going to work out. Okay, so I've got the jury rig grinding jig mounted on the AR5, and if you can hear a little bit of pitter patter in the background, it's raining, I'm sorry about that. So we can swivel about this point to set the drill angle. So I've set the thing here first up to be parallel to this edge, so I can measure it roughly. I mean it's good enough basically for what we're trying to do here, which is prove the concept of the jig, and I've got the dimensions somewhere near. Perhaps that shows it better, that we're parallel along this edge. So therefore it's valid for me to set this edge at 59 degrees. I've checked already that the wheel is parallel to the table, or the table is parallel to the wheel. So now we know that we've got the drill at 59 degrees to the wheel this way, which will give us the 118 degree included angle for the drill point. I'll get this out of the way. Can see that I'll be able to move that backwards and forwards, can move it in to get the contact, and I'll be able to now want to test whether I can get the range of angles that we need for the clearance and the drill relief. So I've got my digital gauge here. I'll set it to 0 in roughly the plane that the drill is going to be in. So now if I put it up here, I can set the angle. So we're currently sitting on 10.4. We'll just check to make sure we can get the range of angles we need. So we've got to go from 7 degrees for a large drill in hard steel. Well, that's clearly no problem. Up to 14 degrees for a small drill in soft stuff. Well, that's clearly no problem. Now I'll just check to make sure we can go in far enough. Yes, there's plenty of travel into that and forward. So I think that we can see that the basic arrangement here, this length, that height, etc, etc, it's all going to work. So I'll go ahead now and go further with this jig, and I'll drill a couple of holes here to bolt this 45 degree piece onto here with a couple of little nuts and bolts. I don't want to weld anything at this stage, because if it turns out to be something's in the way of something else, then that's obviously a problem. But anyway, so I'll bolt this piece on, and I'll cut a slot here, like it was done in the sample jig that I'm inspired by, and make a little indexing pointer or indexing pin, so that when I've got the lips horizontal, I can set it against that to make it easy to turn the drill over. So the only piece of the puzzle at the moment that I haven't sorted is how to actually get these lips horizontal. So I'll have to have a look at that. Got a couple of ideas, but for the moment I'll go ahead and make these refinements that I've just spoken about and bring you back. Okay, so I've taken that clamped together cobble up and made it a bit more robust, something we might actually be able to use. So the mounting bracket is now bolted to the trough, the two M4s I think they are, and I put 3 holes in so I'd have a bit of flexibility with how much of the trough stuck out past the pivot point. So there's that. I put a 4mm wide slot in the end here, so I could have a little button head sticking up and use that to index the location of the drill. It just sticks up enough to catch the edge of the drill flute, and it's just held on with a nut and washer on the back. And to make sure it sat low in the groove, which I needed to allow for smaller drills, I made up a little jig here to hold it, and this allowed me to, hopefully you can see, allowed me to run an end mill across there and create the relief in the back of the head of the screw, so it would sit lower into that slot. And as I say, that just gets held on with a nut and washer. So that gives us the ability to index the drill rotationally. So now I need something to hold the end, and in the lash up I had dowel pin just held with a clamp, the toolmaker's clamp. I've gone a bit better than that, and made a clamping block, and there's a little video here on how I made the clamping block. Okay, so this is the setup that I use for making the adjuster nut that fits in the trough. So I'm not working with the exact dimensions here, just wanted to clean the end up. And for this piece, which I'm going to chop off the end of this length in due course, this piece will end up about 20, but about 20 is close enough. And speed it up a little bit as well now. 1,000, this seems to work quite well at 1,000. Yeah, I think it'll be good enough for that. So now I've got to turn it over and put it flat on this side to get clearance for the curve or fillet in the bottom of the V trough. So this is why I got this apart. So this is actually a shoulder bolt that tightens up against that. And what keeps tension on it is there's a Belleville washer. A Belleville washer is springy steel and is dished. So we'll put this, change the assembly order to offset the depth stop, I'm trying to do this without getting in the way of the camera and not making a very good job of it. So now I can turn this guy over. This setup, by the way, just put a machinist jack in here to support this end of the vise, so when it's clamped up, the vise jaw, moving jaw isn't twisted. Tighten everything up, we should be good. Now we don't need to take off so much this time. I'll just go and check with the ruler. Oh, actually we need pretty much what we did on the, as it turns out, we need pretty much what I did on the first piece. So I think I'll set it back in and make it symmetrical. So now we'll hack that off and then drill and tap a hole in it. Right, so I've remounted this, still in the blocks, to make it easy to find the centre line using the wiggler. I can go off the faces of the jaws, or well, that's the easiest way to do it, off the faces of the jaws, and then off the sides, and I know exactly where I am. But anyway, let's face it off. Okay, so I'm going to put 2 holes through this, and I'll set them up in such a way that they're on the centre line in this direction, but off centre this way, so that by turning this, flipping this one way or the other, I can actually get 4 different centre heights for the screw. So we go over 6 to start with. Yeah, and the other one at 13. So we'll tap these 2 holes. So this clamping block will sit in there with a piece of threaded rod out to the back, so to make it easy to wind it in. And I've made up a clamping ring. This is a piece of 40 nominal bore water pipe, just cleaned up, drilled and tapped for an M6 screw. So that'll go on there. clamp that down, oh, a bit further along I guess. And there we got it. That'll hold the drill, so, and allow me to flip it over to do both flutes. So the other part of the thing is the base assembly, and instead of just having nuts and washers and pieces, I've made up a single combined nut and washer to hold that in place. It was perhaps unnecessary strictly for the proof of concept, but it just made it a bit easier to work with. So that'll go like that, and the this piece will now go on there. Decent sized washer to put a bit of clamping force on. Belleville washer to keep things firm so it doesn't get loose. Snug that up. We'll snug that up. And I think we're good to go. Take it over to the machine, take it over to the grinding machine and see how it all works. Okay, well before we start on the 4-facet grinding, I think I should just skim the wheel, give that a fresh thing after all the grinding I was doing with the conical jig, so let's do that. And that should do it. I just wanted to give it a light skim, open the pores so to speak of the wheel again. I think that'll be good. Okay, well I've got the jig assembled and attached to the AR5. Having cleaned this up, we're good to give it good to try the things out. So first things first, I think we can make sure I've set the back of this parallel to the edge of that, so we can get the clearance angle we want of 59 degrees by setting like that. So I've done that. We need also to set the angle of the trough itself, and to do that I'm going to use the digital angle finder. So we just check what the angle is, the angle reading is there. We'll zero that. Is that readable? Well, I'm not sure whether that's readable on the screen or not, but anyway, I've zeroed it. So then we'll put that on here, and from a reading you're supposed to do the secondary angle first, and I'm going to go for 20 degrees on the secondary angle. So by sheer dumb luck, that's about what it's come out at the moment, on 20 degrees, so we'll call that good. And the other thing that we must do, and in the spirit of full disclosure, this is actually my second go. The first go sorted out a few bugs, not the least of which is I wasn't getting the lips of the drill correctly set horizontal when they're in situ. I made the mistake of trying to set the lips horizontal when this was out on the bench, and it just didn't work out. So I did get a sort of a 4-facet thing, but it mangled the bit along the way. So anyway, hopefully this will make good. So we've got this angle set, we've got that angle set. The only thing left to do is get the lips horizontal, and I gather that the best way to do that realistically is by eye with a straight edge. So we'll have a go at that. That's looking pretty good. And we'll see how that works out. Now I'll make sure my little button is tight so that when I turn the drill round I'll get proper indexing. And I've made a refinement at this end as well. In my first go I had the screw in the back here holding the position of the drill fore and aft, and it vibrated loose. So I've made up this little nut with integrated spanner to just pull the locking action on this screw. I needed to do that because there isn't room down in here for a spanner, a regular spanner. I might show you this later if it's of interest. Anyway, let's have a look and see how we go with this grind. So I've got to come this way a little bit. So, crunch time, let's see if it works. So an inch in. Right, so hold that to its position. We'll go in a couple of 3 thou and see what happens. Turn the drill over. Let's have a look. So that's cleaning up behind the primary lip there. So that's looking quite reasonable. We'll keep going at that. Have a few more goes and then have another look. So the secondary grind has come forwards to consume most of the primary relief now. So we'll keep going a bit further and we'll take all of that primary relief off and start from scratch. We'll go just a bit more, I think, to even things out. So I think that'll do for the secondary relief. We change the angle now and have a go at the primary cutting angle. So what we can see here is the drill tip after the completion of the first grinding operation, which creates the secondary relief. So there's no cutting edge as such yet. It's just all the clearance that's going to be needed behind it. So onto the primary, cutting the primary relief angles. So we've got to change this from 20 to about 10 or 12. Don't think these angles are terribly critical. It's just that you need to be consistent. So we'll go with 11 and a half, 11.78 or something. And when we put the drill back, of course, all the geometry's changed, so we'll have to come back. The drill lip should still be horizontal, but I think we might check that. It's not very easy doing this. The Mark II of this jig's got to have something built in to make that easier to do. That's somewhere near horizontal. I come back, we'll be doing a couple of light passes. Right, just touching now. So we'll go in 1,000 and see what that does. No, maybe another one, I think. Right. And the other side. Have a look at that. So we can see it's just starting to do the primary reliefs there. So we're going to go a bit more. Okay, so we've got more to go yet. The goal is to get the back edge of the the four edges of the four faces, so the back of the primary, and then in the centre of the chisel, so that the four edges all meet at a point. You see the back edges of that primary relief are starting to come in line with each other and to form a point in the middle. We're very close. One disadvantage of having to hold the drill like this is that I can quite unknowingly move this end and change the relationship between the tip and the wheel slightly. So that's something else that isn't desirable. Just do 2 passes for each side since we were so close. So if you overshoot, you have to redo the secondary angle and sneak up on it again. Well, that's actually looking pretty good to my old tired eyes. So I think we'll put that under a bit of magnification and get a closer look at what that point in the centre there really looks like. You can now see the 2 cutting lips and how the jig has managed to get the 4 edges to hit right on the centre of the chisel. So that looks looking pretty good. Okay, well the drill looked alright, the drill point looked alright, but let's see if it can actually drill a hole. Let's go with that 200 RPM. So there's no pilot, let's see what happens. Well, that wasn't good. So obviously put too much pressure on the drill point. I was obviously leaning just on too hard on the feed, and the lips just ripped right off. It's not good. Well, let's finish regrinding the secondary clearance. Took a while, take quite a bit of metal off. Alright, let's go and do the primary again. Okay, well here we go with take 2. I've resharpened the drill, but instead of a 12-degree primary relief, this time I've given it 8. I think I was being a bit unwise trying to drill steel with 12 degrees. So let's see whether this makes a difference. Also, I won't put as much pressure on the drill. We might speed it up a bit too. Say 300. Fingers crossed. It's cutting, but I don't know that it's cutting very nicely. Maybe I'm being too ginger with the pressure. Yeah, now it's getting into it. Yeah, that's pretty good. Well, that was a lot more successful, wasn't it? I might just check the diameter of the hole and see how close to size it was. Well, let's see how big this is. Okay, let's see what we got. Pretty close to 12 really. So let's see what size the drill is. So it has cut oversized. It's not a 1/2 inch drill after all. I keep calling it a 1/2 inch drill, but it's evidently not. I think it must be 7/16 or 31/32s. Yes, 31/32s. So it's gone about 0.02 over, no hang on, about 0.2 oversized, just under 0.2 oversized, which I suppose isn't too bad for a drill pushed in with no pilot. Alright, so let's have a look at the drill tip after it's done one hole and see what it's like. So we can see the edges stood up very well. There's almost nothing to see on the edge of that lip. On the other lip, for some reason the outside corner there has taken a slight nick. But overall, it's in pretty good shape, and the lines, the grind lines that you can see there, you can't actually feel with your finger. You need to just keep in mind this is significantly magnified, possibly maybe 10 times, something like that. So as I say, you can see them, but you can't feel them. So overall anyway, I'm very happy with the way this grind worked out. And this to give you a closer look at the surface finish on the inside of the hole, which is pretty good. Again, you've got to realise this is magnified very significantly. So that's actually a pretty smooth finish. And when I was using the hole gauge, the ball ground hole gauge, that actually slid in and out of there quite smoothly. So that's a pretty good result as well. So I said earlier that I'd come back and have a look at the nut with attached spanner. I don't know whether such a device has a name, a recognisable name. If it has, don't know what it is. Anyway, this started out in life just as a piece of 10mm round mild steel bar, free cutting, and I squished it in the hydraulic press. I think it took about 12 tons. Squished the end down till it was 5mm thick, and in the process of pushing it or squashing it against the bed plate, it raised the back end up, which is exactly what I wanted it to do. Then drilled and tapped for a 1/4 UNC, 20 TPI, rounded it off, and that's it. And just needed to synchronise the thread to the block so that it would come up at the right point and operate within the confines of the V trough. So that's what it does. Locks just as it's coming up there. That's it. Simple, but quite effective. Well, that's it for this video, and I hope you enjoyed it. If you did, perhaps you'd like to subscribe. But I'm going to start work on the next video, which looks at ways to improve on this jig and make it easier to use and hopefully get an even better result.